Hey everybody, it's Wojo. Good morning, good afternoon, or good evening, depending on what time you're watching this. No matter what time you're watching, I hope you're having a great day. Today we're going to take a look at a new calculation on how to calculate dog years. This was in a science journal over the summer. I found it quite interesting and I'm excited to show you, so let's take a look. All right, so let's take a look at how we're going to look at this new calculation for calculating dog years. When I was growing up, I don't know if it's still the same, if you guys heard the same thing, but they said the easiest way to calculate dog years is just take the age of the dog and multiply it by 7. And so in this case, like if your dog was 2 years old, in human years, that would be the equivalent of 14, 2 times 7 being 14. If the dog was 8 years old, it would be like the equivalent of a 56-year-old human. And, for a while, I guess that kind of makes sense. You can kind of get an age of dogs pretty well. But, it's interesting reading the Science Journal. They made a point that I never really thought of is that dogs can start having, their litter, their puppies, 9 months to a year old. Well, if we multiply that by 7, that would be the equivalent of humans having kids at 7 years old. And we just know that's not right. And so scientists looked at Labradors, I think, in particular, and tried to find out a new formula. Now, they weren't the first ones to be looking at this. I mean, if you just Google, I just Googled and found lots of things like how old is my dog in human years. And you can see just by looking at these charts, they didn't just multiply by 7. There's this kind of, 1 year old is 15 and then 24, then 28, and it depends on the size of the dog. So there are different charts, but they try to get even better and more accurate in trying to make a calculation. And so what they came up with in their calculations is something that's more of a curve like this. So it's not like a straight line that when puppies are young, they're like increasing their age quite a bit. So around 1, they're almost like 30 years old or 1.5 maybe, looking at this chart, and they kind of then level out a little bit and they kind of age more gradual. And so you kind of look at this and they say, well, what kind of formula though? I just want something easy, like multiply by 7. And unfortunately, with a math model like this, you can't just come up with something simple. And so their formula was this here, that their human age is equal to 16 times what they call the natural log. And that's kind of what this curve is a natural log curve. The natural log of their dog age plus 31. Now this looks pretty confusing, but for the most part it's not too bad because natural log is just a button on our calculator that we can hit. And so we're just going to have to do 16 times the natural log of whatever their dog age is. So if their dog age is 2, we would do 16 times the natural log of 2 and then add 31. And it gives us a much better representation of at least these Labradors and kind of how their physiology matches a human's physiology. And so like when they're lifespan, the average lifespan, I think, of a Labrador is around 12 years old, and that comes out to about 71 years old for a human, which is, I think, the normal lifespan of a human, roughly, the average lifespan, I suppose. I shouldn't say normal, average. And so just kind of taking my calculator and playing with it a little bit, I just found out how old my dog is by using the new formula, and like a 3-month-old puppy would be about 8 years old. And if you've ever had a puppy, like 2-month-old puppies, they just run around and play and jump and they won't listen and they kind of do their own thing. And that's kind of more like a 4 or 5-year-old or someone that's kind of in their terrible twos, but they outgrow it fairly quickly. And, they kind of get more mature and they become more like a teenager pretty quickly at the 9-month-old stage. Now again, this isn't probably for every dog. They just did Labradors and they kind of looked at the study there. All right, so now let's take a second and I'll show you what that natural log button looks like on the calculator. So if you wanted to see how old your dog was or just kind of curious how it works. And then we're going to use this information to look at why solving is so important in algebra in a little bit. So that's kind of our main goal today. So let's take a look at how to actually use this formula. All right, so let's take a look at the calculator itself, and I can show you where that natural log button is. And we can look at how maybe we could calculate dog years ourselves if we wanted to figure out how old our dog was in human years. So let's take a look at the calculator, and I'll show you exactly how you can make these calculations. So if you remember, I'll just kind of put this to the side here, that our formula was 16 times the natural log of dog years plus 31. So on our calculators, that natural log, that ln, so I keep saying natural log, that is the mathematical term for this ln. That ln on our calculator is right here, and I'll show you on some online calculators where you can find that natural log as well, because I know not everyone has calculators like this, but natural log is a fairly common button on calculators. You probably have seen it before, just never knew what it was. So if I wanted to find, let's say, how old in human years is a 7-year-old dog, because my dog is 7, I'm going to type in 16. You could use the multiply button, or you could just type natural log. It'll know that that's what you want to do. And then you would just put in your dog years. So if I think my dog is 7, I would just put dog years of 7 here. And then I would add 31, and then I would just hit enter. And so a 7-year-old dog would be the equivalent of a 62-year-old. So 7-year-old dogs, at least Labradors, the ones according to the study, would be fairly old. Now you would have to put this in years. So if you wanted to figure out how old a puppy was, and they're like, let's say 3 months old, you couldn't put 3 in there. If you put 3 in there, it's going to think it's a 3-year-old. So 3 months would be like a quarter of a year. So you have to put like 0.25. But that natural log button is pretty easy to find. It's right there. It's usually under the log button. Log and natural log are fairly similar mathematical ideas that we study much more in depth in Algebra 2, but we're just going to take a look. Let me show you for a quick second where you can find the ln button on most online calculators, and then I'll let you guys try some stuff. All right, so we're back at Google. I just wanted to show you really quick, if you don't have one of those calculators at home, you could just type into Google online calculator and just hit it. And one of these calculators will pop up right here. You could just use this one. There's all kinds of online calculators you can use. But if you look closely, you'll see that ln, that natural log function that was part of our equation, was right there. And so just like the regular calculator, you could just type in 16 natural log. Again, you could use the multiply button in between if you need. If we want to look at, well, my dog's really old. He's like 14 years old. How much is that in human years? I would put the dog years there, and then don't forget the formula has to add 31 at the end. And then when you're ready, you just hit the equals. So a 14-year-old dog is equivalent of a 73-year-old dog, and then we can go from there. Now, one of the things that I'll ask you that we can start thinking about now is, well, what if I wanted to know how old my dog would have to live to if I wanted him to be 100 years old? What if I want him to be the equivalent of a 100-year-old? One of the oldest humans, lived to about 100, so I want my dog to live for a long time. How many dog years would that be? I could keep going in and trying things like, well, I tried 14, let's try 18 years. Is it possible? And I could just keep trying over and over and over. That's not enough. I want to keep going up. Is there a way that we could find that answer without just trying it over and over and over again? And that gets us into this idea that we're going to be studying a little bit later, which is called solving equations, and why we might want to solve. Because sometimes you want to work backwards with a formula. You don't always want to go forward. And that's what we're going to take a look at next. There is a few things I would like you guys to try, so make sure that if you have questions, you just send me an email or ask when you see me next. And I hope to see you guys soon. Talk to you later.